Hi all, welcome back to my channel. So today I will be covering why we need powerful GPUs to run any large language model. Let's break it down into simpler terms. First, let's talk about the basic concepts. You might have heard of bits, bytes, right? A bit, if I recall it, what exactly this is. So a bit is the smallest unit of data which is present in the world of computing, represented as either 0 or a 1. 8 bits make a byte. So, a byte is like a small chunk of information. Now, in the world of large language models, we deal with parameters. I have explained in my previous videos also that a model contains billions of parameters. And think of parameters like a building block of these models, right? Basically, these are the neurons of the model. So, if I quantify this parameter, so each parameter typically contains 32 bits of information, which is equivalent to 4 bytes. It's pure mathematics, unitary method. So considering you have a billion parameters, so you are looking at 4 gigabytes of data, because 1 billion parameters multiplied by 4 bytes, which is equivalent to 4 gigabytes, and that's hopping a lot of data.
But there is more to it. During training, we also need to store additional data for gradients, Adam parameters, and optimizer states as shown here. Gradients basically relates to adjustments of model parameters. Adam parameters represent the learning rate, and optimizer track the parameters and their updates during the training, which, considering all these factors, it significantly increased the GPU memory usage, sometimes by about plus 20, as shown here. So the memory demand goes far beyond the model weights what we had seen of 4 GB.
Modern language models are much, much larger. We are talking about models with 7 billion, 70 billion parameters. And that translates to anywhere from 28 gigabytes.
280 GB of data, and that's a lot.
And imagine trying to run that on a regular computer. So it would be incredibly slow and inefficient, right? And this is where GPUs come into play. So GPUs, or the graphics processing units, are designed to handle in such a way that they are able to handle massive amounts of data in parallel. Unlike your standard CPU or the standard CPU which we see in regular monitors, it might struggle with such a heavy load, right? So GPUs can process thousands of tasks simultaneously.
Let me also cover a very important aspect. To handle this huge memory demand, we use a technique called, called quantization. This process basically reduces the precision of the numbers. For example, as we saw that one parameter carried an information of 32 bit of precision, right? Now, with the help of quantization, this precision can be reduced to a 16 bit or even 8 bit of information, 8 bit of precision. This reduces the memory footprint and speeds up the computations. Specifically, quantization helps in two main scenarios, training and inference. Using reduced precision, the training process is significantly speeded up because of the smaller memory footprint and faster arithmetic operations. Now, coming to inference, which is a process where a trained AI model makes predictions or decisions based on the new data, quantization becomes more critical. By moving to lower precision, model size is significantly reduced and the speed is improved. Now, you must be wondering whether this will impact the output. Even though the precision is reduced, the pattern of the data remains the same, and which is why the models can still predict the right output. Large language models don't memorize the data they are trained on. Instead, they learn and understand patterns. Therefore, quantization still helps to make accurate predictions even with the lower precisions.
So when running a large language model, GPUs can quickly and efficiently handle such huge number of calculations, right? So whether it's understanding any natural language or generating creative content or even providing some smart recommendations or intelligently answering your questions, these AI applications rely solely on the power of GPUs from infrastructure point of view, right?
So now you know why companies like Nvidia, who are experts in GPU manufacturing, have shown tremendous growth in recent years.
So in summary, GPUs are very critical for running these models, right? Because they can handle the massive data loads and complex calculations required. This makes them indispensable for anyone working with AI and machine learning. So thanks for watching this video. If you have found this useful or you have learned something new, please make sure to like and subscribe. Thank you.